Hello students, welcome back to my classroom. This is the fourth video lesson. Today we're going to talk about inscribed hexagon. To be an inscribed hexagon, this hexagon I have to put it inside this circle. But I'm looking at the hexagon and it's a little smaller than the circle. To be inscribed, all the vertices have to be on the circumference. So what am I going to do? I'm going to enlarge it a little bit and I'm going to make sure that this side is equal to the radius. Once again, the side is equal to the radius. Well, the radius is this big. Then I have another radius here. And then I'm going to draw another radius here. What did I do? I divided the circle into three congruent parts. If I know that the circle has 360 degrees, I divide it by 3, I get just 120. Ooh, 120. It tells me that I have to divide it one more time. And this one that is 120, I divide it one more time. And this one, I divide it one more time. What am I getting? I am getting a hexagon made of 1, 2, 3, 4, 5, 6 equilateral triangles. If I have now 6 of those triangles, 6 of those angles, I divide 360 by 6, I get 60 degrees. If I have here 60 degrees, then this one would be also 60 degrees. This angle would be also 60 degrees. We already know that inside a triangle, I have how much? 180 degrees. Now, students, what's going to happen? If I have here 60, this also would be 60 degrees. What's my entire inscribed angle? 60 plus 60 would be 120. Watch this. If this is 60, central angle, that's 60. If this is 60, that's 60. Another 60. If this is 60, that arc is 60. If this angle is 60, that arc is 60. Watch what happens. This is my angle, inscribed angle, and it intercepts this big arc, which is 60, 60, 60, 60, 240. Divided by 2, you get 120 because the inscribed angle is equal to half the intercepted arc. 240 divided by 2, that's equal to 120. Well, what do I know now? This angle is 120, 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 this angle is 120. Whoa! I need to come up with a formula. Do I remember from first semester I was saying that n, what's n? Number of sides. How many sides? 1, 2, 3, 4, 5, 6. Woo! N minus 2. What's n minus 2? N minus 2 stands for how many diagonals I got from the same I have only 3, but it forms 1, 2, 3, 4 triangles. So n minus 2 stands for the number of triangles inside the polygon, inside the hexagon. And because one triangle is 180 degrees, this is 180 degrees, this is 180 degrees altogether. This is 180 degrees. This angle, this angle, this angle. I do n minus 2, which is 1, 2, 3, 4. N minus 2 times 180 degrees. Therefore, the sum of interior angles inside a polygon is n minus 2 times 180. Where did I start? I started with inscribed hexagon. I had to move this hexagon inside, and I had to make sure that this side is as big as the radius. I noticed that this big angle, 120, is half of this big intercepted arc. But if I have the same angle right here, it's still 60. It's equal to just this intercepted arc. Why? Because this is a central angle. This is an inscribed angle. Now, students, I am going to come further because the semester is running quick. We're almost finished. The 5th grading cycle is going to be done on the 17th. And I'm going to tell you this. What is this? Did I hear anybody say because it splits the side in half, it's a bisector? And because it makes here 90 degrees, it's a angle bisector? Is it also perpendicular bisector? Is it also a median? Whoa! Is it also a possum? Or is it a pothum? I heard somebody say a pothum, not a possum, because this possum, since the coronavirus, needs to have a mask on. Students, this is my classroom. Welcome back to my classroom. We've been talking about inscribed angles inside a hexagon. I took the hexagon, put it inside here. The side, this side is equal to the radius. This radius is equal to this other radius. If this side equal to this radius, isn't that an equilateral triangle? If it's equilateral triangle, all angles are 60 degrees. Times 3, it's equal to 180. How many things did you learn today? Inscribed angle, central angle. Inscribed angle is half of the intercepted arc. Central angle equal to the measure of intercepted arc. What else did we learn? Number of sides, subtract 2. I have 6 sides, subtract 2, I get 3 triangles inside. Therefore, n minus 2 stands for the number of triangles. Therefore, the sum of interior angles is n minus 2 times 180. How many more formulas you want in the 10 minutes in my classroom? Get back to work. See you next time.